Hi teachers, in this video we're going to look at Unit 2 integers. We're going to start with sections 2.1 and 2.2. So first, just looking at the learning objectives at the beginning. Notice that we spend a considerable amount of time just talking about integers numbers. So representing application problems, plotting integers on number lines. So usually in the past you might have said, hey, here's an integer, let's start doing some operations with them. But we're going to spend some time helping them to understand the concept of integer. So let's look at the first example. Okay, so some pretty basic problems in general. We start with using some sort of application to ground their understanding of something, and in this case, integers. So it asks you to determine the sign number, circle the word that indicates the sign of the number. So Tom gambled in Vegas and lost $52. So I'm assuming you can guess what we would want them to do here. So based on the word lost, so it's lost $52. We think of that as a negative 52. There's just something I want to draw your attention to, that there's a group of researchers who study integers, and they claim that any context can actually be written for something that we might think of as a negative number like this one. We could actually write it as a positive number as well. So I'm just going to draw a little picture. And this isn't something necessarily you'd show your students. It's something I want you to connect to an idea you'll be more familiar with when we talk about the Cartesian plane and inputs and outputs. So if we think of this as an output, the number of money, let's think of it as the dollars Tom lost. Okay, and we say this is time. So when he first started gambling, he had lost $0. But notice at the end, if we think of the output as the dollars Tom lost, well, he lost positive $52. And then who knows, in the beginning, maybe he won, and one would mean negative. Winnings would be negative in this context, and maybe he ends up here. Or we could think of this as the change in Tom's dollars, or the amount of money he has. And at the beginning, there is no change, okay? But we could think of lost as being a negative value. So at the end, if this is negative 52, since he lost money, maybe he won some, then he lost, then he's down here, okay? So these things we take for granted, and we don't want to get too in-depth in the very first example, but you're going to see that we're going to start to build on this idea of defining what it is this is in relation to. And sometimes it's a little bit harder because this is just talking, when we talk about Tom losing $52, it's only talking about this one point in time. We're not looking at it over an interval of time. But we can still define the one-dimensional value, and we'll probably, so think of this as a number line, but we'll probably think of it this way. We can still define this so that losing $52 being a negative value would make sense. Okay, so let's go back and look at the packet. Okay. So Larry added 25 songs to his playlist. So if we think of this as 20, positive 25, added would be the key word. And notice that we'd really be representing the change in the number of songs to Larry's playlist. The airplane descended 500 feet to avoid turbulence. So descended is what's telling us that we would likely think of this as negative 500 feet. But notice that we're also looking at this under the lens of the change in the height of the airplane. Okay, so we start here, and we're just going to start thinking of words lost, added, descended, and what they might represent as sign numbers. Now here we're going to represent integers on the number line. Okay, and if you watch these videos, you'll see that we label the number lines just like we label the number lines in the two-dimensional context so that it makes the negative value make sense. So the temperature in Greenland yesterday was -5 degrees Fahrenheit. Notice this example isn't talking about a change, okay? So it didn't say the temperature in Greenland dropped 5 degrees yesterday. There are contexts where negatives in themselves are numbers and not necessarily changes, and this is one of them. So we might label this number line as the temperature in Greenland. Okay, we have some tick marks, -1, 2, 3, 4, 5, and we'd plot the number here. A few things students do. They like to plot the points above the tick marks instead of on them. So I always make sure that I tell them to plot it directly on the number line. You could see why that would be problematic later. And then also to label the points underneath. If it's not too tedious, I like them to label all of them, but no need to get too excessive. And then notice this new question. What does 0 represent in this context? So this is also connecting the idea of what the referential point is for this -5. So in this context, 0 would represent 0 degrees Fahrenheit, so -5 is 5 less than 0 degrees Fahrenheit. Okay, here's another one about a plane. We love to talk about planes. And again, it says the altitude of the plane decreased by 60 feet. They'll want to label this number line things like the plane, okay? Make sure that they, the height of the plane would be sufficient, but we really want to talk about the change in the height of the plane because the height is decreasing by 60 feet. So notice the height of the plane isn't -60 feet, or else it would be 60 feet into the ground. It's the change in the height is 60 feet. So these little nuances can really help them to understand, to have a better context of integer or concept. Also notice there's 5 tick marks here, and it's 60, okay? So we want them to scale by something that is not 1, okay? So I think in the video I used 20s, so this would be -20, -40, -60, okay? They could also use other numbers on their own, okay? But it's good to get them to try to figure out what numbers they have to use, even if they start by thinking 10, -10, -20, -30, -40, -50. They might put another line here for -60, but they'll start to see that it has to fit in some sort of fixed area, and that their scaling needs to change based on that. Okay, and what does 0 represent in this context? Well, this would represent the height of the plane not changing, so no change in the altitude of the plane. Okay. So scrolling down a little bit more. Oh, and that's all she wrote for these first 2 sections. We'll start the next section in the next video.